Welcome student to this example here where we'll do application of derivative in business. So far, we know how to find the derivative using the product rule, the constant factor rule, and the sum rule. And we will use it now in this example. So suppose the monthly revenue, and remember, revenue should be something that comes in dollars, which means the amount of money that we'll get back after selling a product. Now, suppose the revenue is given by this, where X is the number of product sold. And suppose that the company can only sold up to 800 units. The first part is we need to find the marginal revenue. And then we will see what we need to do next. So what I will do, I'll go to the next page. And the first thing first is we will find, so a solution. First one is the marginal revenue. And the marginal revenue, sometimes we write it MR and we put a bar on top of it. Now, what is the marginal revenue? Marginal revenue is another name of the derivative. That means we need to find the derivative. Just let me remind you of the revenue function. It was 100x minus 0.1 x squared. Now, what is the marginal revenue? It is r prime of x. What is r prime of x? If we have 100, we just write 100. What is the derivative of x? Derivative of x is just 1, and we don't need to write 1. Minus derivative of x squared is 2x. So you will multiply 2 by this number here. So we get 0.2x. This is the marginal revenue. So that we finish from the first part, which is find the marginal revenue. Just the derivative, 100 minus 2 times 0.1x. Next, interrupt its meaning when the quantity sold is x equal to 300. So we need to find r prime at 300, and we need to say what does this means. So all what we need to do is we need to substitute, and instead of x we write 300, and we find this number using the calculator. Okay, let's see what this number means and what's actually in terms of business gonna make a difference. The answer is 40. Now, it is 40 what? Well, actually, always it is, because it's a revenue, it should be dollar per unit, which means as interpretation, it means if we sell one more item, which means if we sell one more item after 300, if we sell one more, it will become 301. After 300 units is sold, the revenue will increase by $40. That is the meaning for the marginal revenue. So if we have, for example, 300, for example, let me just explain it more. If we have a 300 units, let's suppose the revenue is $1,000. If we solve one more, what will be the next number? The estimation of the next number. We don't know for sure, but we want the estimation. The estimation will be 1,040 because I will have 40 more dollars. And that's the interpretation for 300. Let's see what will happen if we have, the second part of the question was if we have 600. So we have to do everything the same. Except we need to change 300 into 600. Now, the answer will surprise you. The answer is negative $20, which means if we sell one more item after 600, which means 601, the revenue will not increase. In fact, it will decrease by $20. We'll start kind of losing money in estimation by $40. That's the interpretation. So always think of interpretation. What will happen if you do one more unit? What will happen to the revenue? Is it going up, and how much up, or down, and how much is down? So we solve this one. We solve 300, 600. Now let's look at the last question. Compare your answer with the rate of change of the revenue from x equal 300 to x equal 301. What is the rate of change? So the rate of change from x equal 300 to x equal 301. Remember, there is a formula, and the formula goes like this. 301 minus 300. Here we write 301 minus, which is the slope. So it is R. Of course, this would be 1. Now, what is, if we substitute 301, we get 200,039.9. Now, if we do the same thing for 300, we get 21000. The final answer will be minus, it will be plus 39.9, which is exactly as we find using the derivative. Without finding it exactly, in the derivative, we estimate this revenue will go by $40. Actually, it will go by 39.9, which is almost the same as our estimation. Next question, we have a demand function. For Q units of a product is given by this formula. Find and explain the meaning of the instantaneous rate of change of the demand when B equal 25 and when B equal 100. So again, instantaneous rate of change is the derivative. Now, what's the derivative? Remember, my function p equal to 1000 divided square root of p minus 1. If we rewrite this one, this is p to the negative half minus 1. And now, sorry, this is q here. Now q prime will be just negative 500 b to the negative 3 over 2. And of course, the derivative of negative 1 is 0. We don't write it down. as the derivative. Next, we substitute 25 and we interrupt the meaning. Now, if we substitute 25, if you have a calculator, just plug in here 25. The answer will be -4 unit per dollar. Now, what does this means? It means if the price increase $1, which means increase from 25, if we take this and we say we will make our product, instead of selling it by $25, I will start selling it by 26. The quantity demanded by the people will decrease 4 units. How do I know it's decreased? Because there is a minus. And why it will decrease by 4 units? This is the demand law. If you increase your price, less people will be willing to buy. That means, of course, the quantity you want to sell will go by 4. So if your product is 25 and you decide to increase it by only $1, you should expect a reduction in your sales. Now, this is the first part. The second part, we will do the same thing, but this time I'll substitute 100. Of course, I substitute in the derivative. The answer will be just 0.5 units. Now, what this means? It means if the price increases 1 unit from $100 to $101, the quantity demanded by the people will decrease by 1 unit. By half units. Which again, something you could expect and something makes sense to you. Why? Because if you have a product which you sell it by $100, if you add only $1, that is not that much of a huge inflation. It's just $1. So the people might, yes, they didn't like it that much, but again, it will not affect dramatically your sales. However, if you are selling things with $25 and you add 1, you really change a lot compared to the original price. But once you reach 100 or 1,000 units, and then you go from 1,000 to 1,001, that change is almost unnoticeable. People not notice that change, and this is the psychology of the consumers. Example number 3, which suppose that the total cost function is given by this formula here. Let me just take it down here. Now, we have the average cost, which we talked about it before, is given by this formula. You take the total cost and you divide it by X. We want you to find the instantaneous rate of change of the average cost with respect to the number of units at any production. Okay, so we need to find the instantaneous rate of change. What does instantaneous rate of change of the average cost? It means the derivative. Derivative of what? Of this formula here. So we go to the next page. Do the solution. continuous rate of change of the average cost. What is the formula for the average cost? Is this one, C bar of X. Now, what is C bar of X? It was C of X divided by X. And this is, if we write it down, this is 4,000 plus 55x plus 0.1 x squared divided by x. Of course, we have to rewrite this function. The way we write this function, we just split the fraction. So let me do it step by step so that we all follow together. So the first one will take x squared. The second one will get x squared. And the last one will get x squared. And this means we have 4,000 x negative 1. We have 55. We have x. Now, all what we need to do is we need to find the derivative of this function. What is the derivative? It will be negative 4,000 x negative 2 plus 0.1. Why? Because derivative of 55 has no x, this will be 0. Derivative of x is just 1, so this number will survive. Which is, we can write it as 4,000 divided x squared plus 0.1. That's the first part, and this is the instantaneous rate of change. Second part, it says find the level of production at which this rate of change equal to 0. So we have to find when this is equal to 0. So part B. I want the instantaneous rate of change for the average to equal to 0. This means negative 4,000 divided by x squared plus 0.1 equal to 0. So what we do is, again, we can multiply the whole equation by x squared so that we get 0.1 x squared, because if we multiply by x squared, minus 4,000 without x squared. Again, the answer will be 0 because if you multiply x squared, this will be 0. This will cancel with this, so you get only negative 1,000, and this one I just write it down here. Now, this is of course an equation that we all can solve. And it will give us two answers. First answer is 200 units. And the second answer will be a negative, so it will be disregarded or rejected. Why it is rejected? Because it's negative. We cannot have a quantity which is negative. So the only answer is x equal to 200. So at x equal to 200, the instantaneous rate of change is 0. Now, what does this mean? It means when you reach 200 units and then you produce one more item, so you move from 200 to 201, the average cost, the cost would be almost 0. So it will not cost you anything if you just add one more item after the 200. And this could happen sometimes if you produce so many things, you still can reduce your production because maybe the material is there, the remaining of the material is there. It's a formula. So if you move from 200 to 201, your